So today we're going to start Unit 2 on transformations. I think that you will remember a lot of this from 8th grade. So today we're going to talk specifically about translations. But to get started, I do want to go over some basic definitions with you that you're going to need for this whole unit. So first of all, transformation is the movement of a figure in a plane from its original position to a new position. Again, that's like what you learned in 8th grade, a translation, a rotation, a reflection, something like that. You're taking something and you're moving it from its original position to a new position. When you do that, there are a couple of terms that you need to know: pre-image and image. Okay, so the pre-image is the figure that undergoes the transformation. Okay, and so anytime you're doing a transformation, the pre-image is going to just be a letter by itself, like A or B, whatever letter it is. Okay, and then your image is the resulting figure. So resulting figure. Anytime we talk about image, it's going to have a prime behind it. That's how we read that, a prime. Hopefully you've seen that before. So the pre-image, the one that was there first, is A. The one that gets there after the transformation, the resulting figure, is going to be A prime. And then we'll talk about this in a different video, but the other definition I want you to see is rigid transformation. And that's what we're going to be talking about in this unit mostly. Rigid transformations are transformations that don't change the size or shape of the figure. So for example, a rotation. If I take my pen, for example, it's the easiest thing I've got next to me. If I take my pen and I rotate it this way, the size and shape did not change. Still the same pen, it's the same size, it's the same shape. The only thing that changed was its orientation. It's now going a different way. I can rotate it again. Still the same size, still the same shape. So this is the example of a rigid transformation. All right, so let's get started. Today I told you we're going to talk about translations. Okay, so a translation is a fancy word for a slide. So in a translation, you're going to move every point of a figure the same distance in the same direction. So if one point moves to the right too, all the points need to move to the right too. You can be described by mapping the rotation, and here's what that's going to look like. We call this coordinate form, and I'll go over more what coordinate form means in just a second. It'll be easier to tell you in an example, but the x value gets something added or subtracted to it, and so that's the x moves left and right, and then the y value gets something added or subtracted to it, and that's going to move up and down. That's your y value. Again, I think the best way to explain that is to just see an example. So here goes. Let me pause for a second, and I'm going to go ahead and graph these for you. Okay, so let's look at this first example. Quadrilateral ABCD has vertices. A is -1, 8. Notice I'm going to write that in my pre-image column. That's my x, y coordinates. It's the pre-image. That's what it is before I start anything. Pre, it's there first. B is 212. C is 5, 8. And D is -1, -2. Okay. And its image has a translation of x plus 12, y minus 5. What are the new coordinates of A prime, B prime, C prime, D prime? Let's look at this rule real quick. It says x plus 12. So we're thinking about our x-axis, and we're adding 12. So that means we're going to be moving it to the right, 12. And then on our y-axis, we're subtracting 5. So your y-axis, remember, goes up and down. So if you're subtracting 5, hopefully that makes you think, well, we're going to go down 5. Okay, so here goes. It's super simple. We're just going to do exactly what this says. We're going to take our x value and add 12 to it. And then we're going to take our y value and subtract 5. So my x value is -1. I'm going to add 12 to it. My y value is 8. I'm going to subtract 5. You do not have to write this out every time you do it. I'm just writing it out so I can show you where I'm getting these numbers from. So -1 plus 12 gives me 11. 8 minus 5 is 3. So there is my point A prime. All right, let's do B. Same thing. Your x coordinate plus 12, your y coordinate minus 5. So B prime is going to be 14, 7. Okay. C, 5 plus 12, 8 minus 5. Again, I'm plus 12 to every x, minus 5 to every y. So that means my C prime is going to be 17, 3. And then my last one, negative 1 plus 12, negative 2 minus 5. So that means my D prime is going to be 11, negative 7. Okay, that's it. Now you also are going to do translations on a graph. So let me show you what that would look like. So here is a graph. Let me see if I can get it. Okay, example number 2. So I've gone ahead and graphed it for you. It's quadrilateral ABCD, and it's got the vertices negative 1, 2. So my pre-image was there first, my pre-image. B is negative 1, 5. C is 4, 6. And D is 4, 2. Okay, now we want to do a translation of x plus 3, y minus 1. So I'm going to do this one a little bit differently just for fun. So it says x plus 3. So remember, I'm looking at my x-axis. If I add 3, I'm moving in a positive direction, which means I'm going to the right 3. And then on my y-axis, I'm subtracting 1. So I'm on my y-axis. I'm subtracting. That moves me in a negative direction. So that means I'm going to go down 1. Okay, I like these better when they're on a graph. It seems easier to me because watch this. I can take my point A and I'm going to move it to the right 3 and down 1. So I'm literally going to count. Right, 1, 2, 3, down 1. My new point is going to be called A prime. And then I'm just going to write down its coordinates as my image because that's my new point. It's my image, my resulting figure. And its coordinates are 2, 1. If you would prefer to literally add 3 and subtract 1 from each point, you can do that to get your image. I like to count when I have a graph. Personal preference. So I'm going to do the same thing to all of these. My B, I'm going to move it to the right 3. 1, 2, 3, down 1. That's my new B. So it's going to be called B prime. And its coordinates are 2, 1, 2, 3, 4. Okay. C prime. Same thing. I'm going to take my C and I'm going to move to the right 3. 1, 2, 3, down 1. So there is C prime. And its coordinates are 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. Okay, and then the last one, I'm going to do D prime. Same thing. I'm going to move it to the right 3. 1, 2, 3, down 1. So there's D prime. And so it's also at 7. And then its Y value is 1. Okay. Again, the points I started with are just my A, B, C, D. After I've done the translation, they become A prime, B prime, C prime, D prime, my image. I am going to connect them in the same way they were connected before, and you'll see that this is the exact same figure. So it's the same size, and it's the same shape, and so it is a rigid transformation. We talked about that vocab a minute ago. I'm running out of room to write my word. Huh? Okay, so it's a rigid transformation because it's the same size and the same shape. All right, last example for a translation. So, let's see. I'm going to start with writing down my pre-image like I always do. So my pre-image this time, A is 1, negative 2. Again, I've already graphed it. B is 3, negative 1. C is 0, 3. And D is negative 4, 1. Okay, so that's my pre-image. That's my X and my Y values before I do anything. right, let's look at this translation. Again, the x is being added to, so it's going in a positive direction. It's moving to the right 2. And my y is being subtracted, so it's going in a negative direction on the y-axis, so that means it's going down 2. Okay. Remember, you can always just add 2 to your x value, subtract 2 from your y value to get your image if you'd prefer, or you can count +2, down 2. Okay, so let's do that. That's what I'm going to do. So my x is going +2, my y is going down 2. There's my new a. I'm going to call it a prime. Its coordinates are 3, 1, 2, 3, -4. So a prime is 3, -4. All right, let's do b. I'm going to move it to the right 2, down 2. There's my new b. I'm going to call it b prime. Its coordinates are 1, 2, 3, 4, 5, -3. Okay, let's do c. Right 2, down 2. So there is my c prime. So its coordinates are 2, 1. And the last one, d prime, I'm going to go right 2, down 2. So there is d prime. Its coordinates are 2, -1. So there it is. Again, when I look at this one, these are the same size and the same shape. Therefore, they must be a rigid transformation. So let's talk about that for just a second. All translations are going to be rigid transformations because of the definition of a translation. A translation says every point moves the same distance in the same direction. So because of that, every translation will be a rigid transformation. It will always be the same size, always be the same shape. After you've graphed something, if you notice they're not the same size or not the same shape, that's going to be a clue that you've done something wrong on a translation. All right, check back later for your next one.